Welcome again, everyone, and thank you for joining this information session on the Certificate in Machine Learning offered through York University School of Continuing Studies. My name is Sean Woodhead. I'm the program manager for the Certificate in Machine Learning. You'll see on the slide up there an artist rendering of a building. Now, this building is what has been recently approved by the York University Board of Governors as the new home for continuing studies programming. I mention this because we do sit at an interesting time in continuing studies programming in Canada. While many continuing studies departments are closing their doors, we're building and expanding. We find ourselves in a good position in part because of how we view quality educational programming. Today, it matters much more what you can do than simply what you know. Our programs acknowledge this and embrace it. The Certificate in Machine Learning has designed its curriculum around what we want you to demonstrate by the end of the program. I'll get into it more in a bit, but those things that I want you to be able to demonstrate are exactly the competencies that various industry leaders and hiring managers told me were critical for someone to be successful in a machine learning related role. And as I said, I'll speak more to that in a bit. I'd like to just quickly go over what we will do for today's session. Traditionally, we offer an information session that runs through all the details of the program, and I believe we'll seek to accomplish that today. But I want to try and accomplish that partially through a different method, which will be an interview with an expert in the field. So today, I'm joined by Carlo Lisi of TD Canada Trust, who I will introduce in just one moment. But before we get to that, just a couple quick housekeeping items. First, during the session, all participant microphones will be muted, and that's just to reduce ambient noise. Second, at the end of the session, there will be an opportunity for questions or comments. You can use either the questions or the chat function that are on the GoToWebinar panel. Now, that will just be, it'll be time permitting whether or not I can address each of the questions in this information session, or if I'll have to respond to those questions afterwards via email. So if we do run short on time, then what I will do is I'll send you all an email with responses to your questions, and I'll make sure that I send that to all of you by tomorrow. So I guess without further ado, let's begin. I'd like to now introduce Dr. Carlo Lisi. Carlo is the Senior Manager of Business Insights and Analytics at TD Canada Trust. For nearly 2 decades, he has worked in the banking sector in various data analytics roles. Carlo completed his PhD in mathematics at University of Toronto, and he's also a York University alumnus. Carlo is a self-described machine learning and Python enthusiast with specialty in text analytics and computer vision, who also enjoys teaching Python and R. Welcome, Carlo.
Welcome, Sean. Thanks very much. Very nice introduction.
And thank you very much for taking time out of your busy schedule to participate in today's information session.
Campus looks so different. I have pictures from the 80s from the York University campus. I mean, you see those new buildings on there, I said, wow, has it changed?
Yeah, absolutely. And yeah, I think that, as I mentioned at the start today, it really is an interesting crossroads in educational programming, and specifically in continuing education programming, as universities need to respond to the needs and interests of our prospective students, of adult learners in lifelong learning. So Carlo, I just wanted to start off maybe by asking, well, you've worked in the banking industry for nearly 2 decades, as I had previously described, and with much of that time in various data science roles. Carlo, what drew you to get into this line of work?
Okay, in a nutshell, really was solving math problems, and also with the computer as well, like in numerical methods. I mean, my PhD was in theoretical math. It was in C-star algebra as an operator theory. And for a long time, I was in pure math. I hardly ever saw numbers. If you're in that area, like topology and category theory, I never saw numbers, all letters and arrows, groups, rings, fields. But what sort of put me, I mean, after that, I did my postdoc. I realized that, I want to apply the math a little bit more than just like do the theory. The theory was great, but so I moved over to computational finance. I found I really enjoyed solving problems with numerical methods. And that took me into an area where you really needed data analysis and programming skills. Those skills are really important. And I found I had a real passion for applying mathematics to solving problems. And so in the field I'm in right now is a good combination of mathematical theory and data analysis and using software to solve problems. That's sort of what got me into it. So once I moved over to computational finance, I really, like when I was pricing, I worked as a market risk analyst, one of my jobs. So I really had to learn how to program, Visual Basic, C++, because that being a quant, that was really important to do. And I just loved solving the problems. It was nice to know the Black-Scholes formula, but all those other derivative pricing formulas, but see it in action. And that really got me excited. I said, wow, I'm going to get into this more. And it sort of led me into this kind of work that I'm into right now.
Excellent. So as you mentioned, that's really what drew you into this line of work that you're in now. How would you describe this evolution of data science across the nearly 20 past years of your work?
I would describe it as it's just, I just from the technology point of view, it's just like so different with the tools. I just think of myself back in the 80s. I would have loved to have a program like this to be able to take what you have. Also, it's just the technology, like going back from I used to do a lot of my analytics in Excel. That's all I had was 16,500 something records. And I kept getting, every time I connected to a database or drew in more records than that, I got that error log. And I just see the technology has really taken things a lot. Not there, the theories developed too, like, the theories developed a lot as well, but the technology, just being able to implement that theory makes the big difference, I believe, in this area, in the evolution of this data science. I mean, the computational firepower you have now compared to what I have, a 386, it's just night and day. I mean, I did courses. There were courses in applied models. They talked about neural nets, machine learning, but I could never apply it. If we were to try to train a neural net back then, maybe one layer would be lucky if we could even do that. Nowadays, I got a gaming computer myself, and if you have an NVIDIA 1070 or 1080, I can run I could even train from scratch some of the models, the public models available for image detection, like Visual Geometry Group 16, VGG 16 or 19, or even ResNet, Microsoft's one that won, or AlexNet, or any of those that won the competitions for large-scale ImageNet competition. Quick descriptions: 1 million images, 1,000 categories, and you have to see if how accurate your model is classifying those categories. Without the technology, I couldn't even. Would never had an opportunity to explore that. And being able to do that makes a big difference. I can actually run my models, I can build my models, run them, and see results in a few hours, rather than having to wait. Sometimes on my work computer, you got to wait a week, actually have to run it for a week to train, a neural net model. And now I can just set up overnight, run it, and check the results in the morning to make more tweaks to it. So I think that it's just really the technologies make the difference. That's what's revived a lot of interest into it. The technology, and of course the methodology comes with it. Like back propagation has been around since '97, and really now that we have better methods, like now it's now only to 2010. It took 13 years later for technology really to get up there to be able to use that, effectively. I think.
I'm really happy that you touched upon that point, because I was going to ask you about how that evolution, like the computational evolution, how that's actually resulted in time saved for you. And you had said something that could have taken you a week before could now take just mere hours.
Yeah, because it also made me participate do a Kaggle competition, and my favorite one is dogs versus cats. I'm just obsessed with that one, and I'm trying to get my best model was 95.26%.
And why is that one your favorite?
I guess I got into it. I just like I like computer vision a lot. So I like to, I love to build convolutional neural nets to classify pictures. So that one, the dogs and cats, it's tricky. It's got some interesting photos. You can't always tell. Some things look like a cat. It could be a dog. So teaching a computer, teaching a computer to actually look at a picture and classify it is just fascinating to me.
I think
that's what I like about that competition.
Yeah,
it's a little easier than the ImageNet one. It's like, it's got 25,000 images, not a million, so you can get the results pretty quickly in a few days. In a few hours. With the other one, you may have to wait a couple of days, which is okay too, right?
Well, I think the dog versus cats, it's a great segue into a question I wanted to ask you about natural language processing and computer vision.
Yes.
So with the fall cohort, who they're now just near the end of their first course, but I recall when a lot of them were considering whether or not they wanted to come into the machine learning program, they had asked about natural language processing and computer vision. Those were the two things that seemed to come up the most. Can you speak to some specific examples of how natural language processing and computer vision are being used in banking today?
Sure, I'd be happy to speak to it. My team has used it a lot. We've built like our text analytics package. We built it in R, but the one we like to use the most is Python's natural language toolkit, which is really good for doing text analysis. And what we've used it for is looking at we can take text, like any text that's around someone's expense claim or in a report, and we can calculate the word frequencies. We also do word clouds, topic modeling as well. And topic modeling is you can read you can have a stack of papers, like pretend books, and rather than you can't read all the books, right? It's a little bit too much, or read every expense claim. Let's say you have expense claims and everybody types words in the expense claim. You can actually teach the model, topic model, like latent dirichlet analysis or the mallet. It goes through each one of those and comes up with the key themes and then all the words around those key themes. So on travel and entertainment expenses, you know what key themes I see? Like lunch, meeting, travel, and then all the words around lunch, different restaurant names. You can see the themes, the topics. And then you look at, it's kind of interesting because each document is a probabilistic weight of all those topics. You're looking at, I know it's counterintuitive, but it's actually, you think the authors create the documents rather than the topics, but that's something I like. That's something that's really like to do, and possibly use it. Topic modeling could be used in so many ways. It gives you some real insights into data that I never could have thought before. And like, how would I analyze all those documents without advanced methods like this? We also calculate things like token type ratio, like that's the number of unique words divided by the total number of words for each person, let's say, or documents, and also like the number of we call something called the HAPACs. These are like linguistic terms I learned from a certain professor in a course that I did, and that's the number of one-off words divided by the total number of words. So you can track those on a monthly basis for certain documents or like expense claims or something that you're looking at, and see what changes. So it's almost like doing real type of like analysis on these words, and that's what I love about it. And we also do like sentiment analysis as well. Like I love to monitor. Here's something we monitor: Twitter tweets. We monitor Twitter tweets about what's being said about us, my bank against all the other banks and some of the US banks I want to track as well. So we want to see what people are saying, see what the sentiment is. And it's not hard to set up, using open source. You can set it up pretty quickly. You can download all the Twitter tweets about York University, using your Twitter handle if you have one, and then you can generate a word cloud. You can see the words being used, or you can see the sentiment. The sentiments are positive? Sorry, it can be positive, negative, or you can do the sentiment categories like anger, disgust, or joy, things, trust, different categories that we can see. That's something that we use. That's what we use for the on text analysis. There's more we can do, but that's something that we're working on right now. And on the OpenCV, there's really good potential here. We can, get all the images and see if forms are signed. You just run the images through the model, and the model can show that, hey, this form wasn't signed, this application form wasn't signed, or this form was signed. Or you can make sure that it's everything's intact. Signed in the right places. You can possibly look at using computer vision for check fraud. I just read a very good paper from KPMG that was published about how they're using images for check fraud. And
interesting.
Yeah, that's more of a different group that does that. I've spoken to them. Different group and security investigations. But there's good potential. You can see not just image classification, segmentation, certain parts of the image. You can see this check fraudulent or not. And if you got enough data, luckily, U.S. checks, or U.S. likes to write a lot of checks. You got tons of data there, so you could train a model to possibly identify which checks could be, you can flag which ones draw red flags that could be fraudulent checks. And there's probably more, and there's probably a lot more in OpenCV that I believe that that we can do. I know we're not going to do things like driving cars, but those are the most exciting talks on this area. But there's a lot of potential, and especially with OpenCV, it's really, I mean, computer vision's got just it's really growing field. It's amazing how you can, monitor things. I mean, I guess that could be used eventually. They'll know all of us when you come on the floor. Camera will just look at you and say, "There's Carlo coming in." It'll know who you are. Basically, they already have that, I think. So that's why I think could be a lot. It can be used in security too, for physical security as well. So there's going to be a lot of applications of that.
Excellent. So I'm thinking, so within TD and obviously in other organizations as well, the use of this technology is having an effect on the hiring practices of those organizations, and it's readjusting who they're hiring.
Yes.
Right. So
you can scan those resumes now. We can actually, there's a little model I think they put together. We can look at the certain keywords and it can score the resumes, and then we can score and we can see which ones we should interview or not.
Very interesting.
Yeah, that can be done as well.
So one thing I'm thinking is with this perhaps realignment of where some of the priority hiring might be within organizations like TD. And I'm thinking, given that you're in a senior manager role and you've done a lot of hiring, and you've witnessed this evolution in data science, I'm wondering, what advice do you perhaps have for those who are trying to get into the field, and then maybe even especially those who are just about to embark on a machine learning program such as our own?
Yeah, it's great. I get asked that question a lot, and it's fine. I'm always happy to answer. For the hiring, what I look for is when hiring in this role, like for say a role on my team, and I look for, and number one is passion for analytics. Key. It's really someone really has to have really has a drive, a strong drive to want to do data analysis. They want to dig into things. They want to get that data. They're willing to learn new methods and come to me and say, "Look what I found. Let's use a certain method. Let's say a package, a Vader package for analyzing Twitter sentiments. That's something that I want to see, that kind of drive, someone who wants to go the extra mile. If they have that passion for analytics, and then next thing I look at is that what programming language have they programmed in? I'm not necessarily looking for a developer. I don't need someone 15 years of Python or R or SAS. I'm looking for someone who has some experience and working knowledge with a tool, an analytics tool. And then with that working knowledge, we can teach them the other parts of what they need. Now, if you're going to get into the field today, I get asked, should I do all these probability theory courses and math courses, linear algebra, then go and do the analysis, the programming? Do I have to be an expert in probability theory? Not necessarily. You don't have to be a Yorkie professor in probability theory, but it's good to, if you do have some of those courses, it's great because it'll show you it shows you what's going on behind the scene, what the model is doing. But the recommendation I have is I say it's great to get into a program like yours where you get some good practical experience. So applying these models, seeing the results, test them out on different data sets. And then after, I find, even for myself, when I apply the models first, then I go to the book Elements of Statistical Learning, and then look at the math theory. I said, I understand better what latent to ritual analysis is doing. It's advanced probability theory. I don't want to scare people. They go, oh my gosh, I got to know advanced probability theory. But I understand it better. I say, I know why it's picking these words, why it's created this topic. You sort of get that, but after seeing a lot of examples, I think, as people, we learn by examples. That's what machine learning is about. You're teaching the computer to learn by examples. That's what dogs and cats does. It learns about, see all the examples of pictures of cats and learns that's a cat. It extracts those features, takes advantage of the spatial, aspect of the data and learns the key features, and says, wow, I know these features apply to a cat, these ones to a dog. So I'm just thinking here, if you learn, once you start running these models and start using them a lot, then I start seeing, now I understand the methods. I know why the neural net is doing this, why it's adjusting the weights this way, why it's not doing a good job, why it's having trouble. classifying certain type of pictures or things like that. So that's what I find. I think it's good to, I mean, I wish there would have been a program, something similar to this, where I would have graduated. I didn't have that. I mean, I just jumped over from, bachelor of math to pure math program for the master's degree. There wasn't this option back then, right? There wasn't this option that to get into the machine learning, but I find that, yes, but I did find that this is a good way to get started, and also to be a self-starter, a self-learner. You have to really always be learning here. We have to learn different things. If something's done in a Docker package, like or somebody's done something in Julia, a different language, from Python or R, we have to be able to pick that up or pick up the new technologies, Apache Spark. So you have to be like a real self-starter and a learner. You're never going to be, you're not going to get to a point after learning more. You're always going to be learning. I'm always learning all the time.
So on that same line of thinking around always learning, I have two questions.
Yeah.
The first, so this is an information session for the certificate in machine learning. First, I wanted to ask you what, if anything, you find particularly remarkable about the York certificate in machine learning program. And then after you respond to that, I'm going to ask you one more question.
No problem, John. I guess when I met with you, I guess it was nice to see you at that Toronto Data Learning Summit there. They had that session. I guess what attracted me to was, number one, the name. I can tell you right now, machine learning. That's good, because otherwise, I've seen business analytics and other ones. Now here to judge anybody else, but I said, okay, business analytics, I've seen that, and they approached me. But it was nice to see the name machine learning, the certificate. That sort of tells you what you're going to be doing. And so I like that. And then I saw the course content. And I did see the Open CV. And I'm a little biased towards Open CV because I love computer vision. Yeah. So I have to admit, I'm a little biased towards that. So when I saw that, that's great, because I haven't seen that before. Open CV, right? And that would certainly, because I want to do more work in that area. And so that would be something that would get my attention if it was put on, a CV on your CV if you did work with Open CV. So that's why I found it, especially those two things. And the Open CV was a good one. The computer vision was good, and also the other courses you're offering too. And it's a good combination of theory and practice in them, right? So I like that. That's what I find very interesting about the program.
Excellent. So the last question I was going to ask. So if we put ourselves in the shoes of the student who, let's say, perhaps they come to this program after they completed a baccalaureate or a master's or even a PhD, like we have a lot of masters and a couple PhD grads in the current cohort that we're running, but they do that, and then they take the certificate in machine learning at York, and then let's say they get like a data science or a machine learning engineering job or what have you. Where would you advise that they continue to stay up to, like, what advice do you have for them on how they can continue to stay up to date in machine learning beyond completing the certificate in machine learning program? And assuming that we're not so quickly offering program after program after program where I would love them to always be able to come to us, but what would be good supplements on top of our machine learning program?
Oh, good supplements. I mean, I find, to be on top of what's going on in machine learning, I sign up for the R bloggers to know what's going on with what's going on in R.
Okay.
And also, there's also Python news groups that are out there. I guess there's different ones like on the computer vision, there's PyImage Search. I mean, that's the conference I went to. That's under Adrian Rosebrook there. And there's also, like, I keep, and often I get emails all the time with the new things that just go like I can't keep up anymore. I get these different emails. So there's certain Python groups like I sign up for, like I just get news events. Also, like different, I get like predictive analytics worlds, another one. They send me different seminars and conferences that are going on, and I just get, I've been to so many different seminars and vendors. I get them always sending me emails when the next one is, when the next webinar is, when the next seminar is in Toronto. I try to attend these as much as possible. Also, like I like to book learn. I'm sort of old-fashioned, so I go to Pack Publishers. They have a lot of different books and training videos. There's Coursera, Udemy as well. Members of my team do that as well. Like there's, I do help them out, pay for a course on there. And some of those courses, like I think you mentioned, Coursera's got a really good one. There's a lot of good courses out there. And I guess there's other ones as well. Maybe I'm not aware of, but those are the ones that I've been looking at. So there's packed publishers, also O'Reilly. You buy a year membership to them. I also find buying with O'Reilly, you don't sort of don't buy the books anymore. You sort of like just you pay an online like a fee every year. You can access every one of their books with one fee. Same with pack publishers. I pay a fee and I can access all their books and all their videos. And you can just watch the videos online and learn. So I like to spend my time learning all the time. And because I'm theoretical in a way, like as a mathematician, I always have cute problems to give myself. Like, I know problems I can give myself. How do you do this? There's a mathematical thing I've done. Oh yes, how do you do this with Python? Like, how do I do an integral, like calculus integral, like, numerically with Python? So I learn things I know how to give myself things like that. But also there's good data sets from UCI, University of California, Irvine, and also Kaggle. If I want to practice on something, apply something to data, grab it off Kaggle or UCI, and just so many, there's hundreds of thousands of data sets out there. So that's probably my best advice there. Keep reading those books and watching the videos. I guess that's what
Excellent.
I'm practicing, and keep practicing too.
Right, great. Well, Carlo, thank you very much for having this discussion with me, and I'm sure that all those that are on the webinar that they appreciate it as well.
Yeah.
Okay, everybody. So I just did a quick little time check here, and we're almost at 12:30. I need to do a hard stop at 12:45. So what I'm going to do here, I'm going to try and go through the rest of the information session fairly quickly. And there's a little bit of a surprise at the end as well that I think will be appealing to at least most of you, if not all of you. So I'm just gonna get right into it. So why study at York? This sort of segues from the last little piece that Carlo had been speaking to about what's perhaps remarkable about the York program, and as well, what are some of the good supplements to the York University program. So I have, as you'll see, 6 points up on here on what I believe to be particularly remarkable about the York University program, and I'm going to go into detail on each of these. So the first item is that we have an outcomes-based curriculum. Now, for many of you, I'm sure that you've seen on a course outline before where it'll say that the objectives of this course are ... or where it'll even say that there are certain outcomes that students would have to demonstrate. And I do think that there's some educational programs that do a good job of providing an outcomes-based curriculum. Now, what I want to say to all of you is that this program was designed entirely around a series of program learning outcomes. I have the first 5 up here that you can read while I'm speaking, and then I'll put the other 4 up after you've read these. So back in November of 2017, when I was at the Toronto Machine Learning Summit, I had an opportunity to speak with hiring managers and other industry leaders from across different industries, and most of whom are based in either Toronto or Montreal. And the question that I posed to them was, what are the specific competencies that you're looking for when you're hiring a junior data scientist who's focused primarily on machine learning, or if you're hiring a machine learning engineer? So after the summit, over the course of 3 to 4 weeks, with a group of 15 individuals, we came up with these 9 learning outcomes that really represented a high level of those competencies. When you read across these learning outcomes, what you'll see is that it's quite technical, but it's not just technical. That you'd be working end to end on a machine learning solution, but that on top of that, there's also business and ethics pieces that we've put in here. And that's because these businesses had been telling us when they were hiring people either straight out of a master's or straight out of a PhD, or when they were being hired into a position with very little business experience, they really had a hard time assimilating into that business environment, truly understanding what was most critical for the business. And so we've really tried to integrate that into our curriculum. The next piece, which touches upon that as well, it's the experiential learning approach that we use. So with experiential learning, the underlying belief is that you as an adult learner, that you will learn better when you do, and when you understand process, and when you're working with the tools and in the software. And like Carlo had mentioned earlier, when it's good that you know the math, and that'll get you to better understand why a neural net might be working in a particular way or what have you. It's absolutely critical that we get you spending as much of your time doing in the program. So across the 3 courses that precede the capstone course, it's mostly a lot of lab work and hands-on tutorials with very minimal lecture. So I just mentioned the capstone course, so I want to then just quickly go over another distinguishing feature of the program. So as you go through the program, you do develop a portfolio. You develop a portfolio of work. The reason that we think it's important that you develop this type of portfolio in the program is so that when you graduate and you're sitting in an interview, you can point to specific examples of work that you've completed. Now, in the capstone course, I think it's particularly important to note that you're working on an unsolved business problem. So we partner students up with businesses, and then they're working with the business on identifying the problem and developing hypotheses and scoping out the project, and with other units within that organization, like the data engineers and DevOps, with business units, and then you work end to end to solution. And the reason that we think it's important that you work on some of those preliminary pieces as well is because the feedback that we had gotten from the organizations that we're partnered with, they said that one of the biggest issues for a data science team is when they're working independently in their own silo, and then they get to a solution, and then they bring in the data engineers who then tell them that there's no way that they can ever ship that solution to production. And then so how much time is wasted on that data science project? So the reason then again that we need you to graduate with that portfolio is so that you have that in hand at the interview, and so that you don't just graduate with the certificate, that you actually graduate with real experience as well. So another distinguishing feature is the program format. So there's lots of good examples of machine learning courses and programs that you can take on Coursera and Udemy, and there's also other examples of programs that you could take where it might be a 2 or 3 semester full-time program. This program, it's a part-time program that is designed primarily for people who are already working. It's not contingent upon you that you do work, but it's really it's designed so that it's not too onerous on you while you have other professional and personal responsibilities. So the format is that you're on campus for a 3-day weekend once every 8 weeks, and that's for a total of 8 months. So then in total, you have 5 on-campus periods. So then in between each of those increments of being on campus for a full day for 3 days in a row, you have some light online learning over the course of 7 weeks. So this is then designed so that you have a bit of a sprint for 3 days, and then you relax, and it's a much slower pace for 7 weeks, and another little sprint for 3 days, and then light online learning, and then so on and so forth. The reason that we went with this format was because when we were initially designing the program, we had reached out to a number of prospective students who fit the demographic makeup on the professional profile of who the program was ultimately designed for. And they overwhelmingly had said that this was the preferred format as opposed to a more traditional method, or even in opposition to, say, a complete online learning experience with no in-person component. And what I can say is that with the students that are currently in the program, they have communicated that they really do appreciate having the in-person component to the program. One thing that is really important to highlight is the connection that this program has to community. So I have up on the screen here a series of organizations that we're partnered with, most of whom are sitting on the advisory council, and the advisory council provides high-level direction to the program on what the competencies should be of our students who are graduating. They give us advice on how to integrate ourselves with the community. And so yeah, I have those organizations up there. And maybe one thing that I should highlight, that out of all these organizations, I find that for our program, its connection to the Toronto Machine Learning Series is really the most important one. So the Toronto Machine Learning Series has both a summit and expo, the next one taking place in November, and I'll give you more details on that in a minute. But they also run bi-monthly evening events where practitioners of varying levels of specialty come together and listen to talks on various different items relating to machine learning and artificial intelligence. Some are business focused, others are very technical focused. But we really have found that this is an excellent community of practice for the machine learning practitioners, but also for our students to get involved and to learn from those who are currently practicing, and for them to even start to develop their own professional network in the Toronto community. And then the last piece that I'm going to speak to is the experience of our instructional team. So up on the screen, I have each of the 4 instructors for the program. So we have Hashmat, who is the instructor for the Machine Learning and Business Context course, which is the first course. He's also currently the Senior Director and Managing Enterprise Architect at the Cooperators Group. And then Dr. Annie Lee, she is the instructor who introduces students to the entire machine learning life cycle in the second course. And she is also currently the research scientist for natural language understanding at Strategy AI. And she's worked in data science and software development roles across multiple sectors. Dr. Karthik Kuber is the instructor who will have students go deep into a number of activities and also introduces students to deep learning. He's taught at Syracuse University, and he was recently a data scientist with Microsoft out in Seattle. And then just about a month ago, he came to Toronto, and he is now a senior data scientist for RBC. He's also a certified deep learning instructor with NVIDIA. Some of you might know of NVIDIA. And actually, I should mention too, in his course, he actually uses some of the NVIDIA deep learning labs, which is pretty cool. And then last but not least, Dr. Faiza Hadari-Kabaz. She's the instructor for the capstone course. And again, that's the course where students are working directly with businesses on unsolved business problems. And she was selected in part because of her experience supervising co-op students at RBC while she was Director of Data Science and Data and Analytics. Faiza is now the head of data science at RBC Capital Ventures. Okay, so I'm just looking at the time. I got 4 minutes left. So the admission requirements. We expect that students are coming in with roughly a second year university level linear algebra, calculus, probability, and inferential stats. Students do need to come into the program with programming experience and preferably in Python. If not in Python, then I would suggest in R. But if you are unsure of if you're at the required level for entry, then what I would advise that you do is you take the self-assessment that we have up on the certificate machine learning webpage, and I have the URL down at the bottom of this slide. And then when I provide you all with answers to questions by email tomorrow, I'll make sure that I include that the URL in that as well. So enrollment is open for winter 2019. Again, the URL is up on there. And the cost of the program is $67.99. And now to get to that surprise that I had promised you all. So I had mentioned to you the connection that our program has with the Toronto Machine Learning Summit. So the Toronto Machine Learning Summit, it's taking place on November 20th and 21st. It's taking place at the Carlo, which is in downtown Toronto. It's at Yonge College. And what you can do is, if you're interested in going to the summit, you can use the promo code that I have up on the screen here, York-Friends-discount, all in capital letters. No strings attached. You don't need to be a student in the program in order to use that discount. But one thing I do want to mention is if you're planning on enrolling in our machine learning program, then you would actually qualify for their student all access pass if you are registered. So then maybe just give me a quick heads up if you're planning on registering and for the program, and then we could talk about getting you the less expensive price for the summit. But the promo code, it's a good discount. It's 50% off. So the regular cost of the ticket for the 2 days is $500. So yeah, it's $250 off. And then if you're if you're a York student, then I believe it's only $125 with the discount. So that's pretty good. I have some contact information up on there. So Elspeth Stanaland, she is the continuing studies advisor for the machine learning program. You can reach her at continue@yorku.ca. If you're ready to register, then you can reach out to Allison if you have any questions, but you can register right through the website. And then if you do want to reach out to me before I email you all with responses to questions, you can just reach me. My name's Sean Woodhead, and my email address is woodhead@yorku.ca. That's WOODHEAD@yorku.ca. So now I'm going to ask if you have any questions, please put them in either the questions box or the chat box. I'm not going to have any time to respond to the questions right now, but as I promised at the beginning, I'll give you responses to all of your questions by tomorrow. So what I'm going to